Today we will solve a problem about XOR gate. So like A XOR B using NAND gate IC, just only NAND gate IC, and our IC will be 74HC00. It is a NAND gate IC which has, I already shows the gate IC's diagram, so which has 14 pin. So there is one, so 2 3 4 5 6 7, so one is here and it has 4 NAND gates. So there is input and there is output. So here and this is a ground, pin number 7. So it's 1 2 3 4 5 6 and it is 8, and this is the power, positive. So we can give this power to 3 to 5 volt, and it is 14, pin 14. So like this, 9 10 11 13 14. So there is a gate input for another NAND gate. Here is another NAND gate. So oh, my drawing is not so good. So now A XOR B. So what is the main calculation? If we put here like A XOR B, two inputs, so we get A naught B plus A B naught. This is a normal XOR operation. So if we did it like this, A naught B plus A B naught, two whole double naught, so these two knots is cancels each other, so it becomes the previous calculations, A naught B plus A B naught. And here we use the De Morgan's theorem that if we put like A plus B naught equal A naught dot B naught, so here it becomes like A naught B naught, it's separated, A B naught and the last naught, the first naught separated. So we will use these inputs makes the whole input. This is the equation to get this operation. So A XOR B. So the diagram, like we will use just only NAND gate. So like this, we put two inputs A and B, and here comes A. So we took here an AND gate like this. So we merged two input of this NAND gate. So A, here is one A, so it gets A naught and it comes here. Another will be B. So we have to first find the A naught. We get A naught and we have to get the B, just only B. So another NAND gate will be just only B. Okay, like this, just for only B. So this NAND gate will be input A naught dot B, so the output will be whole naught. So we get this A naught B whole naught. Another will be A B naught whole naught. So this A comes here and it becomes directly connected to an AND gate input. So this and this B comes here. So this B have to be naught. So we have to get the B naught. So this will be B naught. Sorry, this will be B naught. So now this is B naught. So we get here A. This is not merged, there is another input, so it takes from here B naught. So here comes A B naught whole naught. So we get another input A B naught whole naught, and here A naught B whole naught. So these two inputs gets to another NAND gate like this, and it becomes A naught B dot A B naught whole naught, and this output gets total whole naught. So this will be our operation. This seems like this. This is the breadboard. I already connected the two bus lines. So if you want to know about the breadboard system, how it's work, so go to my another videos where I introduced the breadboard system. So now we will use 274HC00 IC. It is 74HC00 ICs. So here is, I put IC. This round circle is introduced the one pin number 1. This round, not this round circle. You can see a curved mark in front of this IC, and it starts from here 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So 14 pin is for power, so we have to power the both of the ICs. This is for power. Another, you have to look the system how I put. This is for another power. Pin number 7 goes to ground. We have to make the ground and power both of the ICs carefully. Here is pin 1, then pin 2. I use the pin 1, pin 2, pin 3, pin 4. So this is for one input, this is for another input, and this becomes the output for one NAND gate, if you see the diagram carefully. So first of all we get the A naught. So we have to merge the inputs of the first NAND gate of this IC. 1 and 2 merged, and it goes another NAND gate to input. So 3 is output of this NAND gate, and it will be another input of 4. So we have to merge the 1 and 2 and 3 and 4. For input, red LED, a green LED, and this will be for our output. For input A, we will use here the green LED, and for input B, we will use the red LED. 220 ohm resistor. Carefully see the connections. If you don't know about the resistors, you can also see which value it is, the color code, the red and brown, red and brown, and this is for tolerance. This, if you don't know about the color code, you will get another, there is a calculation, of course. We get A naught just for this NAND gate. So this is, we see 1 2 3 an AND gate, and 4 5 6 another AND gate. So 4 3 4, and this is another NAND gate 4 5 6. So there is an input for 4 is, we get A naught. This is A naught. So we have to get a B to 5 in 5. So we put a B. Red LED is for B. Okay, this is shorter. We have to take another jumper. Okay. So at pin 5 we put B, so we get for the second NAND gate A not B, so we will get A not B whole not, and another input will be A B not whole not, so we have to put A. So this output from 6 we get A not B whole not, right? This will be the last NAND gate input, so we rest this NAND gate and work another side of this IC. So there should be a B naught. Now this our A B naught whole naught, so we will get a B naught. So we merging here this 1 2 and 3 4. So we put here a B, we can put it from here, so we will use red. Here's a B. So this is a technique of using breadboard. So this is B, so we put both the input. Now 4 5 3 4 merge, another will be A. So another input is at pin 5. Here I put here you see input A. Carefully look at all the pins. So now this output goes another NAND gate. So here is another NAND gate input, which is 13 pin. Okay, comes from here's the 6 pin, and here is another input. So this output will be our output for A XOR B. We put this LED for output. So we have to put an input here. B is 1, so the output is glowing. You see B output 1. So what is our truth table say? Let's just check. Our truth table is A and B. So if we put 0 and 0, our output will be 1. No, 0. XOR for XOR gate it is 0. If we put 1 and both of 1, the output will be 0. If we put any one of them into 1, so the output will be 1 or 0, it becomes 1. So this is our truth table of XOR gate, 2 inputs. So it's 1 and 1, it is glowing. If we put both of them 1, so what happens? Like this, so the output gets 0. You see the connection is loose in somewhere. We missed this input from this, the first input for A. Here is the A. Now not this, it should be this. And here's the B. The B is red LED 1. A is green. So if we put here 0 1, so the LED is glowing. If you put 1 1, right, the LED is not glowing. Check this. And if we put this A to 1 and this is to 0, and the LED is glowing. So we solved a problem about XOR gate with 2 input. In the next video we will solve another math. So please get in touch and subscribe my channel. 74HC00 is for 4 NAND gate.